talking about a cell responding to its energy needs. One of the best ways to describe that is the so-called energy charge, or EC for short, or Adnillate energy charge, AEC, it's the same thing. It's a number that ranges from 0 to 1. 1 is all ATP, 0 is all AMP. If you think of the three possible ways, you can clip off one phosphate and get an ADP. If you clip off the second phosphate, you get down to AMP. Some reactions will generate this, some will generate that. And so those are the three main characters in the adnillate pool, ATP, ADP, AMP. And it's the relative blend of those that gives you the energy charge. So this is the formula. In this formula, ATP counts as 1, ADP counts as a half of what ATP is worth, and AMP has no value at all. So if everything's in the form of AMP, according to this formula, there'd be nothing up here, that would be 0, and so your fraction would be 0, this would be all AMP. As you start phosphorylating and converting, eventually you'll reach a point where if it's all in the ATP form, that would be 1 over 1, so energy charge would be 1. So you can think of it as like a battery status indicator.
Professor, are you going to give like on the exam like numbers?
Okay. Yeah.
Can we do an example?
Well, let's do an example on this next slide right here. This shows the concentration of the different forms as a function of energy charge. So here is ATP in the solid black line. So at an energy charge of 0, there's no ATP. When you go to an energy charge of 1, 100% of it is in the form of ATP. These are percentages of the different types, ATP, ADP, and AMP. So right here at an energy charge of 0.5, this is the midpoint, we've got equal amounts of them, right? The ADP is at about 33%, ATP is about 33%, and the dotted line, the AMP, is also 33%. So, let's see, to do an example. So this would be like 0.33 plus half of 0.33, that's 0.16 something. So that would add up to 0.5 and 0.3, 0.3, 0.33, 0.33, 0.33 would be 1.
It would only be 0.33 on
At that point, yeah. At that midpoint, they're all at 33%.
Okay.